Right, now we're on to reverse percentages. So when we think about those ideas we just looked at in the first video, all right, to answer question 1 here. So whereas before we were moving forwards, for instance, something increased in price. So you increase the price by working out 100% plus whatever it was. If it was 12% more, so 112% of it. Okay, and you get your increased price, or whether something was being reduced by 15%. So then you worked out 85% of that price, and then you got then reduced price. Now, when it comes to reverse percentages, okay, with reverse percentages is much more of a challenge because they don't actually tell you the original price. Okay, it's your job actually here to work out the original price. Okay, so you're working backwards, right? They actually tell you what the new price is. So here, if we look at question 1, it says in a sale, the original price of a television is reduced by 38%. The sale price is £899. Okay, I'm shading that because it's so important. Calculate the original price of the television. So that there is not the original price. Okay, it didn't start off with that. That is the sale price. That is what you get once you reduce the original price by 38%. So the reduction has already taken place. Okay, you might be wondering how on earth we're going to deal with this. Now, if you think about it, all right, okay, the original price, remember, we said represented 100%. Okay, the original price, okay, the RRP, recommended retail price or whatever, is your 100%. And then what happened to it? It was reduced by 38%. In other words, okay, 38% got taken away from it, and we ended up then, if you take that away, you get 62%, don't you? Okay, 62%. Okay, so think about it now, right? What we just looked at. So reduced by 38%. So now we've got 62%, okay, of the original price will give us our sale price. Okay, we need to think about it that way. The original price has been reduced by 38%. So what we're actually doing is working out 62% of the original price. We don't want 100% of the original price. 100% of the original price is not what it is. Okay, we want, in this case now, to recognize as 62% of the original, because that's what the sale price is, isn't it? 62% of the original is £899. But what's great from here is, if we've got this set up here where we know now 62% of the original price is the sale price, which is £899, we can do a bit of maths here now and it becomes straightforward. Because 62% is 0.62 as a decimal. R is just times. You've got that, and it's easy, isn't it? Okay, because you can get the original now, the original price. Of course, you're timesing it by 0.62. So take it over to the side, do the opposite, divide by 0.62, and you will get the answer straight away. Okay, so I get my calculator, 899 divided by 0.62, and it comes out straight away 1452. Okay, 1452. Okay, so that was the original price. All right, so let's have a look at number 2. Very similar, right? Every question now is very similar technique. It's worth going through all of them. It says here, the bill for repairing a washing machine came to £151.68, inclusive of VAT at 20%. What was the cost before VAT was added? Okay, now VAT is a tax, okay, and it gets added to most goods. When it says here inclusive, that word just means it includes it. Okay, so it's already including this tax of 20%. Okay, so this price actually represents the washing machine bill, but also the 20% already added onto it. So the tax is in here as well. We want the cost before VAT was added. Okay, so we want the original. That's what we want, don't we? The original. Okay, use that word all the time. We want the original cost before the VAT was added. If you think about it, the original always represents 100%, and VAT was added, value added tax, 20% was added to it. So that ended up with as being 120%. Okay, so in effect what we do then is you work out 120% of the original, okay, price, and that then obviously gives us then this total here, which is inclusive of the VAT. So 120% of the original gives us this, and again we just got maths. 120% is 1.2, okay, 1.20 doesn't matter. 1.2 of means times, okay, and again you times in here, so to get original on its own you take it over and you divide, okay, and you get your answer. So I'll get my calculator, divide by 1.2, and I get there's my answer there, like 126.40, obviously put a 0 there, £126.40. Okay, there's a couple of questions more to look at, and then hopefully the understanding is there. So question 3 says, in a sale, the price of a shed is reduced by 30% of its original price. The sale price of the shed is £182. Again, notice they tell you the sale price. They don't tell you the original. Okay? Right? It's up to you to work out the original. Okay? So, you know, it'd be silly to work out, you don't want to be thinking this has been reduced by 30%. No, not at all. The original price has been reduced by 30% and you're left with this. That's the sale price. So if we think of the original, again, always original is 100%. It was reduced by 30%, so we're left with 70%. So working out 70% of the original will give me the sale price. Again, just a bit of maths. 70% as a decimal is 0.7. And then the original then, 182, of course, because you times it by 0.7, you divide by 0.7, and you get your answer. Okay, so 182 divided by 0.7, it comes out straight away £260. Okay, right, the last question we look at now, right? A bit wordy, but the same idea coming across again. A government announcement stated that the number of people who are unemployed this year is 2.24 million. This was a drop of 3.3% from the same time last year. Okay, calculate the number of people who were unemployed last year. Give your answer correct to the nearest 1,000. Notice they want last year's. It's like the one before, isn't it? That's what it's referring to, the original one. Okay, this time, of course, it's last year's one. But what was it before? Okay, so in terms of working out last year's one, let's think about what's going on here. It was a drop of 3.3%. So if we think of last year's, again, I tend to use that word original, representing 100%. There was a drop of 3.3%. Okay, so you work that out on your calculator. I think that's 96.7%. Okay. You check on your calculator, make sure that's right there. 96.7%. Okay. So if we work out 96.7% of last year's, okay, that would equal 2.24 million. Okay, now we don't need to change that. You could leave it like that for a minute. You don't need to write it in terms of numbers. We could put it as 2.24 million. Now in terms of this year, now remember to change that to a decimal. All I'm doing is dividing by 100. Okay, that's all you do, and that's 0.967 times, of course, and then you just do your maths. So to get the original, you divide. Okay, so I get 2.24 divided by 0.967. So I get this here, 2.316442606 million. Okay, now we want this to the nearest 1,000. Now, because there are 6 zeros in a million, okay, we could multiply this by 6. You've got most of the marks so far. You've got 3 of the marks, but to get to the nearest 1,000, you need to multiply. This by a million. Okay, because you've got a million here. You just need to multiply that result by a million. So 6 zeros, isn't it? Yeah. And you get 231,642.606. So that would be 2,316,442 if you just put a comma there. So you've got 2,316,442. So the nearest thousand would be 2,316,000. Okay, excellent.